21 says if a binary operation star is defined by x star y is equal to x plus 2y, find 2 star times the quantity 3 star 4. So imagine that you just crossed into another world of math, and in this world they use this symbol. And this symbol always means to do this. This you are used to. So they want you to find what 2 star times the quantity 3 star 4 is. Remember, by your basic rules of operation, that you always do what's in parentheses first. So we're going to start off with this 3 star 4. Okay, so what would you do with 3 star 4? Looking back to this, you're going to take the first number and add it to 2 times the second number. So the first number is 3, and you're adding it to 2 times the second number. So 3 plus 2 times 4. So that means that this quantity is now represented by this, which you can do easily, is 3 plus 8, which is 11. So I rewrote it, and so I said instead of the quantity 3 star 4, I wrote the quantity 3 plus 2 times 4. And remember that you're still going to do something with that once you figure out the inside. You have to take 2 star whatever you get. So I went ahead and solved, and I said 2 star times the quantity 3 plus 8, which is 11. So now I have 2 star 11. So now I'm just going to do the same process again. I'm going to take 2 plus 2 times 11, because that's what this original process told me to do. So 2 times 11 is 22, and 2 plus 22 is 24. And that is option C. Question 22 wants us to find 2p plus q when p is equal to 5, the matrix 5, 2, 3, 1, and q is equal to 4, 3, 2, 5. So, well, first I found what 2p was. So here I had p, 5, 2, 3, and 1, and I just multiplied by 2. So now 5 times 2 is 10, 2 times 2 is 4, 3 times 2 is 6, and 1 times 2 is 2. And I'm adding it to q. So my next step would be to simply add these numbers up. And so you just add what's in the same spot, in the corresponding spot. So here we have 10 plus 4 is 14. 6 plus 2 is 8. 4 plus 3 is 7. And 2 plus 5 is 7. And so your answer is option D. Question 33 wants us to find the inverse of the matrix, which consists of the numbers 5, 3, 6, 4. So to take the inverse for a 2 by 2 matrix, you can follow this formula over here. So if the first inverse is set up, if the first matrix is set up like this, A, B, C, D, then to get the inverse, you're going to take 1 over the determinant of the first matrix times the numbers of the first matrix jumbled around like this. So A and D switch places, and C and B stay where they are, but they become negative. So let's apply that to this over here. So this will be our original. So here we have 5, 3, 6, and 4. So we can find the determinant by taking 5 times 4 minus 6 times 3. And then, sorry, I set that up here, and we can simplify that later. And then to get the second part that we need of this formula, we're going to switch the places of the A and the D numbers. So 5 and 4 switch. So now 4 is here and 5 is here. And then you're going to leave C and B where they are, but you're going to make them negative. So now this is negative 6 and this is negative 3. So moving on, we're going to simplify. This is 1 over 20 minus 18, which simplifies to 1/2. So now we're just taking this 1/2 and multiplying it by the numbers in this matrix. So now we have 1/2 times 4 is 2, 1/2 times negative 6 is negative 3, 1/2 times negative 3 is negative 3/2, and 1/2 times 5 is 5/2. And so that matches your option D. Question 24 says, in the diagram above, find the value of x. So here we have two triangles, and they want us to find the value of x. So we're going to use what they gave us to our advantage. So this angle right here is 150 degrees. This one is 110, and we want to know x. So first, and hopefully you can see the line that I'm drawing. This straight line, well, first off, it's a straight line. Straight lines have a measure of 180 degrees. So this full angle right here is 180. If I subtract 150, I'll have this inner angle. So 180 minus 150 is 30. Okay, so now I know that this inner angle is 30. I know that inside of a triangle there are 180, so I'm getting pretty close to finding out what x is. Next, I'm going to add these two angles. So 30 plus 110 is 140. And now, to find out what x is, all I have to do is take the full measure of the triangle, which is 180 degrees, and subtract 140, because that's how much these two are added up together. So now, my final answer is 40 degrees for angle x, which is option D. Question 25 wants to find out what the value of x in the figure is. So, what we need to do is take our knowledge of parallel lines and angles and put it all together. So, first off, we know that since this is 110 and this is a straight line, this full angle is 180, meaning that 180 minus 110 tells us that this inner angle is the 70 degrees that I've labeled up here. Using that same process of information, I took 180 minus 120, and I got that this inner angle was 60 degrees. And then because this diagonal was crossing through the two parallel lines, this being 70 degrees makes this angle also 70 degrees. Okay, so that helps me out a lot more. So now I know that this is 60 and this is 70, making this final angle here 50. And that's because 70 plus 60 is 130. So 180 minus 130, going from here to here, 180 minus 130 is 50. So remember back to the question that they're asking us, which is what is the value of x? So now I know that this is 50, this inner angle here. And so the value of x is going to be, and now this is starting to get kind of crowded, I know. So I'll try to find a different color and maybe make the line a little thicker. I don't know how much thicker. Okay, that's good. This straight line here is still 180. This inner angle here I just figured out was 50. That means that 180 minus 50 will give me the value of x. So 180 minus 50 is 130, and the answer is B. Question 26 gives us the angles of a quadrilateral, and it tells us that it asks us to find the value of y. So in a quadrilateral there are 360 degrees total. So that means that if I were to add up all the measurements that they gave me, I would get 360. So what I did was I took all of these and I added up as best as I could. So 3y plus 2y is 5y, plus 1y is 6y, plus 4y is 10y. So that's how I ended up with this, 10y. Then I took 10 plus 30 is 40, plus 20 is 60. So here I'm at 10y plus 60 is equal to 360. So the next thing I did was I subtracted 60 from both sides. So I'm left with 10y is equal to 300. I divide by 10 on both sides, and I find that y is equal to 30, which is your option C. A square tile has a side of 30 centimeters. How many of these tiles will cover a rectangular floor of length 7.2 meters and width 4.2 meters? So, the total area for this rectangular floor can be found by multiplying. Also, notice that they gave me this, meters, but this one is in centimeters. So what I did is I converted this 7.2 meters into centimeters and the 4.2 meters in 2 centimeters as well. The way that I did that was I just moved the decimal point over 2 spaces because it's multiplying by 100. So 7.2 times 100 would simply be 720. So that's what I did for both of these. So to find the total area, I would have to multiply 720 times 420. So, but before I go on and do that, that's my total area, right? But what are they asking me? They're asking me how many of these tiles will cover a rectangular floor. So what I did, and I wrote it out here, to get tiles needed to cover area, divide by area of one tile. So again, they told me that one tile has one length that is 30 centimeters, and because it's a square, so is the other one. So the area of the tile is going to be 30 times 30, which I wrote here. So what am I doing here? What is this step? Well, I'm taking the area of the room divided by the area of one tile. This saves me from having to do the math of first 720 times 420, then 30 times 30, then this number divided by this number. This way I can just easily simplify as I go. So I crossed out these zeros, and I'm left with 72 over 3 times 42 over 3. And so I went ahead and I simplified that. So I know that 72 divided by 3 is 24. And you can see my scratch work over here on the side. I knew it would go into it. And then 42 divided by 3. The way that I knew that I could divide these easily is because 7 plus 2 is equal to 9, which is easily divisible by 3. And 4 plus 2 is equal to 6, which is easily divisible by 3. This trick of checking if you can divide by 3 only works with the number 3. But anyway, so I did 72 divided by 3, and I got 24. And I did the same thing for 42, and I got 14. And then I finally multiplied those two numbers. I got 336 tiles as my answer. And that is option B. Question 28 wants us to find the length of a chord which subtends an angle of 90 degrees at the center of a circle whose radius is 8. So here I have a circle, and it wants us to find the length of a chord which subtends an angle of 90 degrees. So here is the 90-degree angle which they speak of, and the radius is 8 centimeters. So that means that, pretending that this is the center, going out is 8 and going out here is 8. So the next thing we need to do is use the Pythagorean theorem. So this length, AB squared, is equal to 8 squared plus 8 squared. So I'll have AB squared is equal to 64 plus 64, which 64 plus 64 is 128. So I'm taking the square root of both sides. So now I have AB is equal to the square root of 128. I split that apart to make it a little bit easier to work with, so that's 64 times 2, as I just saw up here. That means that I can take 8 times the square root of 2, and that will be my final answer for length of AB, which is the chord that they were asking about. And that's your option D. A chord of a circle subtends an angle of 120 degrees at the center of a circle of diameter 4 square root 3 centimeters. Calculate the area of the major sector. So, they said here that the diameter is 4 square root of 3. I wrote that out here, that's the diameter. So our radius will be half of that, so it's 2 square root of 3 for the radius. And remember that the radius is only this length. The area of a circle is pi r squared. So I plugged in this radius here. And I squared it because, well, that's what you have to do for the area of a circle. So I'm left with 4 pi cubed, or excuse me, 4 pi times 3. So that was equal to 12 pi. 4 times 3 is 12 pi, and that's the area of the circle. But remember, they're asking they're asking to calculate the area of the major sector. So what do I have to do next? Well, remember that they said that it's subtending an angle of 120 degrees. So the entire circle has 360 degrees. The area they're interested in is 120 degrees of it, which means I'm dividing it into 3 parts. So I'm only interested in 1/3 of the full area of the circle. So here's the full area, and now I divide it by 3 so I can get the 1/3 that they're interested in. And so my final answer is 4 pi centimeters squared. And that's option B. Question 30 says the locus of the points which is equidistant from the line PQ forms A. And so I drew a simple diagram to illustrate the point here. So the line PQ is here, and they want the locus of the points that's equidistant from this line. Well, that would be a perpendicular line to PQ. And I'm going to try to draw a line that's perpendicular here. It's not very well drawn, but you can imagine. So that line, this line, consists all points that are equidistant. So this point and this point equidistant. This one and the next one equidistant, and so on and so forth. So that's why the answer is A.